Okay, so you have a situation where you have a bank customer struct, okay? And this bank customer has a balance member and has an interest rate member, okay? Say a teller at a bank wanted to view two these two members, but the customer doesn't want you changing these two members. Because you can simply do this. You can simply do inside your main function, create a variable for this bank customer. So you can do struct bank customer Bob, right? And you can give Bob these two values. You give Bob a balance in his bank, and you give Bob's interest rate. You can actually set these for Bob. Okay? Say Bob didn't want people screwing around with his balance's interest rate, right? Let me just compile this and show you that I can change what's inside here. You see that? I can actually view what's inside of Bob's bank. And I can change what's in Bob's bank. I can do this. I can do Bob.balance is equal to 0. I can take all his money. I can take all Bob's money. Look at this. See, I'm running away with all Bob's money. Bob has no money left. This is what introduces you to something new. I have to introduce you to something different in order to protect these member types. Okay. First of all, we can introduce you to a new keyword called private. Now, what private does is private can make any of its member functions or variables inaccessible from the outside. So I can access balance or interest rate from the main function. So if I try to access this, let's see what happens if I try to access this. So it gives me a bunch of errors because I can't access private data type. Now this comes in handy this time when I have a bank customer, right? Because this bank customer has his own balance. He doesn't want people tinkering with his balances. He doesn't want people screwing around with his interest rate. So if he's able to protect this stuff, then we have to make a function inside of bank in order to display the stuff if I wanted the stuff to be displayed. So I can control what I want to be displayed. So we can actually make our first function inside of this, okay? So we can make use of functions, right? Just like this display function. We can make use of this function to access these private data types from the main function. So if we were to make a new instance of Bob, of bank customer, called Bob, okay? We can actually make a function from inside here to access the balance and interest rate, but it can only be controlled through this function. I can't control it. All I can do is I could call display and I could change stuff. So let's do this over here. So first of all, just like you'd control anything else, just like you'd instantiate anything else, you may display, okay? And this is how it's declared. So we have the void returns nothing, right? And the name of the struct, which is bank customer, two of these colons, which signifies that we're accessing a function within the struct, not a global function, only a function that's within the structure. So it has to be within here. We're only accessing types within here. We're not accessing global variables. We're accessing variables within the struct. Okay, that's what these two signify. We can simply assign a value to this function or to these member types, right? So we can do literally balance is equal to. We can do that, right? We can see out the balance. So we first have to tell what we want to print out, right? So we can actually do Bob dot the display function. So Bob dot display. What this does is this display function uses the Bob variable name and sends it to the bank customer, right? And it creates a balance for Bob and it counts Bob's balance. So we can't control it. We can't do this. We can't do Bob dot balance is equal to this. We can't do that. We have to use functions such as display in order to control what Bob had in his bank. We can't do it from the outside. We have to do it within the structure and within private types, okay, within functions. So let's compile this and see what it gives us. So we have 5600. We sent Bob the display function, right? We called the display function, sent in Bob, created Bob over here. We can create Bob as many times as we want, right? Create as many bank customers as we want. We declared the header over here, so void displays the header, and void display can have access to these two since it's inside the struct. And so this is the actual function here. So void bank customer. We need to instantiate that name, and then we need 2 colons to describe that we're only accessing variables within this struct. We're not accessing global variables. We're not accessing. We can't access. If we had an int x, we can't access this x from this function. It simply won't work. So if we try to do x equal to 56, right? If we try to access this x within here, we can't do that because it only has access to variables inside the struct. Another thing I want to get into is we can actually send structures and change the structure values from a different function as well. Okay, let me show you how to do that. So let's make these 2 variables just public. The default for any structure is public, so any of these variables will be public until we actually have to say it's private. Until we say it's private, each of the variables will be public. Okay, so these are 2 public. We can actually access them, right? We can do bob.balance. We can do that, right? See, that works. In order to send a structure to a different function, right? So if you had a function called change, if I want to accept a struct, we'd have to first put it inside the cast. Okay, now inside the cast, if we want to actually change the structure's values, we can simply do struct, and then we do space, and then the structure name. So that's like saying int, right? We can do this, but it's not really needed. It's just like saying integer x. We don't need the x when casting. We need the struct keyword to signify it's a structure, and we need the struct type, otherwise known as a variable type, which is the bank customer. Okay. So we have this. That means we need this inside the actual function header. Then we need the name Bob, or you could rename it. Okay, you can have Robert, whatever you want. Okay. So if it wants to be called Robert, just name it Robert, and we can access Robert within this. But if you wanted to change Rob's balance inside of a different function, say we wanted to do that, we'd have to send the address of Bob. Okay, so when calling the change function, so we have to do change and then in brackets the ampersand and then Bob's name. So within the cast, we can do simply just asterisk. Okay, so we have the asterisk. I can go right over here, okay, and I can go right over here. So we have struct bank customer. That's just like saying int, okay. So int is just like saying struct bank customer. Int is like bank customer, okay. Need the asterisk right there, and need the asterisk right over there, and that's the variable name. So we send Bob as a address, so we can actually change Bob.balance. In order to change Bob.balance, we can't just do this, right? Because you know that we need the asterisk. But the thing is, the dot operator has greater precedence over the asterisk, so it'll try to access Bob.balance before it tries to point. So we have to change this by simply using brackets around the asterisk and Bob. So first it points to it, then it'll use the dot operator and access one of its members. Another short form for doing this is we don't need any of this stuff. We don't need the dot operator at all. Okay, we don't need the brackets. We simply do just a little slash there, and then the this symbol over here. Okay, the arrow. Okay, so we can actually change Bob's balance. So we can make it 5600 if you wanted to, and then we could output Bob.balance. So we can make it 23, right? And then we can output before we send it to this function, and then we can output after. and we get this new balance. So I had to change it to Robert because we called it Robert. So Robert.balance equals 5600. There we go. See, it's 23, right? 23 over here. We call this change function, right? We send the address of the struct, and then we can access its individual member by the hyphen and arrow, and then we can make it 5600, and then we output that again, we get 5600.